Hello again, ladies and gentlemen. Today we are going to be doing the integral from 0 to 1 of x squared minus 1 divided by the natural log of x. Now, this is another question that we can't do with integration by parts. I know it looks like, we might be able to do it, it's what we do when we normally, divide by something or times by something, but this stupid function on the bottom is just painful. In order to integrate that, it'd just be an entire mess. So what we're going to do is we're going to introduce a new variable like we did earlier. We're going to denote this as I. So we're going to denote this integral as I. Now we're going to introduce my favorite variable, alpha. So we're going to know I of alpha is equal to the integral from 0 to 1. Now we're going to replace this 2 with an alpha. Replace this 2 with an alpha. Minus 1 divided by the natural log of x dx. Now, as a result of this, we can see that when alpha is equal to 2, we get our original question, we get our answer, right? So what we're going to do now is we are going to differentiate. This is called Feynman's technique. We differentiate with respect to I of alpha. Now the reason we can switch these around, we take the derivative inside of the partial derivative, is because these bounds right here are not in terms of x or alpha. These are just numerical. They will not knock anything up, so we can just interchange them in between. Now, so what we do when we take the derivative of it, we times by the natural log of x. Now, the great thing about this is if we have a to the x and we take the derivative of it, that goes to the natural log of a times a to the x, right? But now, because we're taking the derivative with respect to alpha, we're multiplying by the natural log of x. Now, because this is just constant here, that does not matter when we're differentiating. So, what we're going to do is we're going to see that when we get I prime of alpha equals the integral from 0 to 1 of x to the alpha. Because when you multiply by the natural log of x, you're just going to cancel out that bottom one. And this doesn't count because negative 1 over the natural log of x, well, that's just a constant when we're talking in terms of alpha. So now we have alpha, and we have our integral. But now this is really, really nice. We can integrate with respect to x now. So if we integrate with respect to x, well, what do we get? It's just reverse power. So we get our x to the alpha plus 1 divided by alpha plus 1 from 0 to 1. Now look how easy that is. See? We just simplified the entire integrand, and now we have reverse power rule. Now what this equals to, well, we just sub these letters into x. Now when we put 0 into this, 0 to the power of anything is just, 0. So 0 divided by that is just going to be 0. So that's fine. But now we're plugging the 1. Well, we have our 1 to the alpha plus 1 divided by alpha plus 1. Well, that's just 1 over alpha plus 1. So that equals 1 over alpha plus 1 plus, actually no, we don't need to do a plus c because we're that great. Now that is our formula for I prime of alpha. But now we just want I of alpha, don't we? So what we're going to do is we're going to take the natural logarithm. So we're going to take the integral, which will result in the natural logarithm. So I of alpha is equal to the natural log of alpha plus 1. Now we don't need to times by the inner derivative, well we do, but the inner derivative is just 1, because the derivative of alpha is just 1, so we're timesing by 1, it stays the same thing. But now we have to do the plus c. So what we're going to do is we're going to sub in some value that will lead this integral to be 0. So that makes everything easier. Well, if we plug in alpha equals 0, then this becomes 1, and 1 minus 1 is 0, and 0 divided by the natural log of x is just 0. So the integral of 0 is just 0. So that gets our whole thing. So we have I of 0 equals the natural log of alpha of 0 plus 1 plus c, but we see that the natural log of 1 is always just 0. So we see that if that's 0, then c must be 0, which just makes our life so much easier. So in fact, this is actually our result. And what did we say? That when alpha was what now? We get our answer. Well, when alpha is 2, we get our answer. So alpha of 2 equals the natural log of 3, and that is our answer to this incredibly monstrous integral that is actually incredibly easy. It is the natural log of 3. And there you go.